I'm ready. So your time starts now.
We're revolutionizing how you capture photos with our novel lens technology. I'm Holden Beggs, and this is Scope Photonics, an award-winning startup founded by 5 nanotechnology engineers. Our lens product has a multi-billion-dollar market potential that spans several industries and is solving a problem that's hobbled camera technology for centuries. Lenses are ultimately the same as those Galileo used to look at the moons of Jupiter 400 years ago. They're just fixed pieces of glass or plastic that need physical movement to zoom without blurry photos. And physical movement can often be totally incompatible with the application. For example, smartphone cameras don't have the space for physical zoom, so they use extra cameras and digital cropping as a sort of band-aid solution. But they're running up against the brick wall of rising costs, software limitations, and honestly, room on the backs of your phones. The problem exists in dozens of other industries too. Think of medical imaging, where a great diagnosis may depend on how closely a doctor can inch a camera towards the subject, or self-driving car sensors, robotics, entertainment, and more. Lenses underpin modern society and technology. And with the rising need for faster research, faster transportation, faster manufacturing, faster information, lens optics urgently need innovation. We're leading the charge to solve that with our novel adjustable lenses. They use nanotechnology and electrical controls to zoom in without quality loss, without physical movement, and without digital cropping. Not just zoom either. Our lenses can tune their optics to enable wide angle, telephoto, macro, and zoomed photography in just a single camera. They can dynamically adjust for distortions to maintain crisp imaging. And less cameras needed means much cheaper and smaller systems. Basically, they're the Swiss Army knife of lenses, a telescope compressed into the size of a dime. This means always snapping sharp photos, what smartphone companies have spent years working to approximate, with only a single camera on the back of your phone. Now that's our whale of a target, but with the hugely widespread opportunities our lens technology actually has, we're set to competitively enter multiple beachhead industries before even going to smartphones. Specifically, we're first targeting microscopy, manufacturing surface vision, and LiDAR imaging, for all of which we've already secured several letters of intent. With our technology, microscopes will be able to adjust their zoom without these sample-destroying vibrations caused by current and expensive physically zooming models. Scientists could literally watch neurons spark in a sample of tissue live. Manufacturing vision and surface inspection tools can be enhanced for increased efficiency and reduced waste, helping us transition towards cleaner and smarter industry. And autonomous vehicle LiDAR sensors will possess the longer range and high resolution they need to become reliably safe and widely adopted. That's all made possible by the novel liquid crystal nanotechnology that underlies our lens optics. If you're unfamiliar with them, liquid crystals are small molecules, a bit like grains of rice floating in a gel, that rotate when we push an electric field through them. Their rotation changes how light bends when passing through. Our lenses hold hundreds of millions of carefully oriented liquid crystals. So with just electrical signals, they can shape light to create the best possible image. We can make our lenses dynamically refocus or correct for optical distortions without any physical movement, and a stack of them powers our revolutionary zooming technology. Our completely custom-built simulation pipeline lets us design and optimize new lenses with a speed and accuracy literally unseen in liquid crystal research. We then build and test our technology in state-of-the-art fabrication and optical characterization facilities. And because our system involves not only novel lenses, but novel zoom optics, electronic controls, liquid crystal formulations, adaptive software algorithms, and more, our IP strategy is far more aggressive and multifaceted than the average hardware company. We're not just patenting the lens, but everything around it. And what we can't patent, we're developing as trade secrets. All of this intellectual property is solely owned by Scope. Our main smartphone camera target is a fast-growing $14.9 billion market with a CAGR of 9.1%. Getting our technology adopted by just one major company like Samsung would capture at least $3 to $5 billion of that market. We are already in discussions with the senior directors of several major smartphone camera teams and have MVP demos scheduled soon. Our other markets are also all worth at least $1 billion. Early on, we'll be partnering with old LCD, liquid crystal display, foundries to manufacture our tech rather than continue to do it in-house. since LCDs are being phased out of modern usage and the foundries are actively looking for new things to build. We have made sure all our technology remains closely compatible with those existing supply chains. We'll also be building relationships with larger lens manufacturers, since many of them work with both our early and smartphone markets, which would make for a smoother transition between them. As of now, we've built proof of concept lenses, our custom simulation pipeline, and begun filing provisional patents, with one already filed. Right now, we're nose to the grindstone developing new technology. In July, we'll have our first MVP and begin demos to smartphone and lens companies. Soon after, we'll begin beta tests and initiate our first fundraising round. By October, we'll have beta validation complete for our manufacturing inspection market, and we'll have secured our first revenue with a competitive product. We'll have expanded our team to at least 10 people and be developing relationships with major OEMs as we scale up our development. By April 2022, we'll be shifting to contracted manufacturing and selling to our early markets as we begin our first smartphone alpha project. Our competition tends to fall into two main buckets. The first is those just adding more cameras and software processing to quote unquote approximate zoom, like Core Photonics. Core Photonics was actually acquired in 2019 by Samsung for $155 million for their 3-4 camera systems, giving you an idea of what acquisitions in this space can look like. In the other bucket are competitors working on novel lens optics, like diffractic, optotune, and varioptic. Unlike their variety of rotating, squeezing, or electrowetting lenses, our lenses rely on zero bulky motors to operate. Also, these competing solutions can only produce a simple spherical wavefront, while our spherical and aspherical lenses achieve better distortion correction and camera versatility. Our incredible team brings extensive optics and engineering experience from Apple, NASA, Harvard, MIT, and more, along with entrepreneurship and venture capital backgrounds. We met during our nanotechnology engineering degrees at the University of Waterloo and bonded over a shared fascination in cutting-edge optics. Scope actually began as a student capstone project. The company has won national and international recognition as the runner-up for the Global James Dyson Design Award and has been noted in Discovery Channel, The Guardian, and Logic Magazine, among others, for innovation. We're also fortunate to have incredible advisors. Dr. Bob Lemieux is the U Waterloo Dean of Science, a prolific liquid crystal researcher, and has served on the International Liquid Crystal Society's board of directors. Dr. Van Goo is the author of over 30 optics books and has served on the Optical Society of America's board of directors and on the International Commission of Optics. Ted Morgan is a Harvard Business School entrepreneurship case study who sold smartphone technology to Apple, Samsung, and Google. Our team is also supported by world-class facilities and mentorship from Velocity Incubator, Communitech, and more. We've already secured almost $250,000 in non-dilutive funding that's given us a strong runway to revenue. New investments and funding would be used in a two-pronged approach. The first involves strategically hiring new liquid crystal specialists and electronic design engineers, along with upgrading to finer control equipment. These new R&D resources lead to lenses with better performance and more photographic capabilities, meaning more patents and an even stronger competitive edge. The second prong surrounds expanding our beta trials to encompass new verticals and better prove out our technology. We'd also develop new strategic partnerships with LCD foundries to scale up our manufacturing months ahead of schedule. This means we could more efficiently transform our novel IP output into new products and exponentially higher sales. At Scope Photonics, we're changing how the world captures photos with our unique adjustable lenses. They zoom without blurring, correct for distortions, and adapt to different photographic modes, all without movement. We've built proof of concept lenses, secured several LOIs, and begun filing multifaceted patents. Our incoming MVP in July and revenue in October are followed by the $14.9 billion smartphone camera market in the years after. Scope's expert team is supported by globally recognized optics and entrepreneurship advisors, state-of-the-art facilities, and hundreds of thousands of dollars in non-dilutive funding. All of that means we're well on our way to revolutionizing compact optics and are thrilled to finally bring cameras out of the 16th century and into the 21st. Thank you.
Well, thanks, Holden. What a great presentation. As my daughter would say, want. I didn't mention that my hobby's photography, and I'm like forever struggling with focus. So I get it loud and clear. Judges, we now have 5 minutes for questions. Who's got the first question?
I do.
Daryl?
Oh, sorry.
Sorry.
Daryl, you
ahead,
go
Eva.
first. Daryl, you go first. You have been very quiet.
So question is, you've got a lot of verticals there to consider, and I'm hearing sort of a number of LOIs. Just wondering how you end up narrowing it down to one vertical you can tackle first, and are there other verticals that are perhaps smaller opportunities that you might want to partner with somebody that's already in the space with already contracts with autonomous vehicles or other kind of areas?
Yeah, for sure. So how we pick our markets is obviously based on, market interest and their specific needs and whether we can meet them. But internally, the way we pick them is basically by looking at smartphone cameras and looking at all the things we'll need to achieve to really deliver the product that can be integrated into their cameras. And for example, the optical quality, optical capabilities, all of that, but also really compact electronics, for instance, which is hard to do and takes a long time. And so you start looking at markets that don't require compact electronics, for instance, where you can focus on the optical quality, focus on the camera capabilities first, and then shrink down the electronics when you're able to prove out that core value proposition and get that funding. So we've been looking at markets that basically hone in on the key value propositions that our technology provides, and really trying to find those that are most urgently in need of them. We've been approached by smaller markets for sure, and we are more than willing to collaborate with them. Some markets require a significant modifications to our technology to operate, most don't. So that's also a consideration, is really whether they work in a similar vertical as most compact camera applications. That's how we've arrived at our main three, and we seem to have arrived at them well based on letters of intent and the discussions we've had. That being said, it's a pretty cool technology with a huge number of applications. So we're always looking for new opportunities.
It's a very impressive product, and I have to kind of like hats off to you guys. The technology is very amazing. I just want to kind of understand a little bit about the software implementation that's necessary, because I can see that basically the hardware piece is the PCB, and then you just have to drive electricity into the PCB to kind of control that little crystal to change the curvature of the lens.
Exactly.
But when it comes into the actual implementation in, let's say, a phone, then the software integration is actually far more, right? You have to be able to kind of work with, have hooks for the iOS to control the board, and then the board control your device. So tell me a little bit about your plan when it comes to software for these pilots that you have. So obviously controlling the phone manufacturer to controlling your device versus the microscope controlling your device is drastically different. So what's the software implementation that will look like for these pilots?
Yeah, so I'll kind of answer your question moving backwards, start with smartphones, move to your kind of main question of the pilots. So with smartphones, typically when you're taking photos right now, they use a ton of software with like 3 cameras to actually take 3 or more photos at once and then blend and blur them together and estimate what the actual photo should look like. That's when I say approximating zoom. That's essentially what they do. With our technology, essentially what we do is we figure out all the different lens curvatures that can be created based on those voltages. And one of our co-founders is a machine learning expert that has already helped start expediting that process a lot. And you start basically programming in all those different shapes with the different optical characteristics. So what the phone does is says, I want a camera that looks like this. And it prompts to find the closest possible one and then inputs those voltages, which is not a really demanding task when you start thinking of like blurring like 4K photos over top of each other and doing all those edits live, especially when you start getting to streaming video. Modern phones suffer a lot with that. For our early markets, you're also correct that something like a microscope is a way more rudimentary software situation than a phone. With the example of a microscope, our actually really interesting value proposition there is not even the zoom. It's high quality and it's good, but it's because microscopes right now, if you want to zoom in just to adjust kind of fine control, you move a stage and that vibrates the sample and causes like hours of delay. Yeah. Ours, you don't need that. So in our situation with a microscope, the software is actually incredibly simple. It's literally just focusing in, focusing out, and adapting for distortions. Adapting for distortions happens automatically. The focus in and out super easy. So the short answer is we have software people on our team developing it. You're right that microscopes are easier. Smartphones, we're actually pretty happy that we are doing a hardware solution rather than the software that's been longstanding.
Well, that's the end of our time. Yet another great presentation. So thank you. Thank you. That was great. Judges, you have 5 minutes to do your deliberation. And